Students and young professionals all around Europe came to learn from a practical perspective how to operate and maintain a ground station and how to receive radio signals coming from satellites and decode their data. Especially set the focus on finding applications that are freeware so that it doesn't cost anything. Usually, when you work as a flight controller, you never experience what effort it took to carry the signal into that quiet flight control room. In this workshop, the students learn the required steps needed to be able to receive a signal coming from a spacecraft and what steps are to be done to pre-process the raw signals in real time until the final product, the image, the telemetry data, or just simply the satellite's beacon can be displayed on the screen. But what is perhaps the most interesting thing is that the students don't come in an artificial created learning environment. Still, they learn the skills using real satellite as they pass over the ground station. In this way, the students get a rather physical experience of the art of mission control. But first of all, the students were introduced to the basics, like for example, how to read and follow a step-by-step procedure and how to operate a radio receiver using WebSDR. A global network of web-based satellite radio receivers that can be controlled in real time, and how to decode the received signals. After that, they track the satellites on their own using one of our 3 teleports.
It's just for like eyeballing it. If you don't want to know it's precise, you can calculate it for us.
It's there right now, and we're here. It's going to take a while for it to get there.
Yeah, this one ours, when the satellite elevation of the one I selected is above 0. Here for all the ones I made this checkbox.
Hello, my name is Steve. I'm from the UK and I study space engineering at Cranfield University. And I managed to come here for spacecraft operations because you don't really get the chance to indulge in this sort of area in the space industry very often. And some of the things I've liked most about today is that first moment when you pick up the signal and you get really excited about it, but also being able to use these skills and take it home and be able to replicate these things back home in your own comfort.
Would you decide again to come here if someone would ask you?
I would absolutely recommend for people to come here. No question, absolutely recommend it, yeah, it's been fantastic.
And tracker,
Then you put the location of your station, and then because now you have the radio station, but you still need to know when will my satellite pass over that radio station.
okay. Firefox Edge, we try to for the clouds.
Oh yeah, someone's having a bad day.
Yeah, press this button.
Then right on.
This one to generate index passes. So there is your next pass. And you can just click OK. Here you can see when the satellite is showing up. If we're going in 188 azimuth. And this is where we want.
Hello, I'm Pablo. I'm from Spain. I'm 22 years old, and now I'm studying in United Kingdom in Cranfield University, and I'm doing a master's degree about astronautics and space engineering. Like 1 month ago, I had the opportunity to come here. They gave us like a chance to come here, and I decided to apply because I think this is a really good opportunity for me because I wanted to know more about operation, how everything works with the operations with spacecraft, and I think here in Aachen with the operation facility team I'm learning a lot, and also I'm making good friends because yesterday we tracked some satellites, we got some pictures about weather satellites, and also we had some fun in the night drinking a little bit of beer, well not a little but and yeah, having a lot of fun, and I really like this weekend with these guys. Thank you.
In the meantime, the Soyuz MS-13 was on a fast-track 4-orbit rendezvous with the ISS and would begin the docking procedure when being over the German airspace at 22:30 UTC to complete over southern Russia at about 22:45 UTC. After dinner, some of us went back to receive it each time it would pass over our GS. From social media and NASA TV, we knew the orbit insertion time and we verified the location of the ISS at that time using the TLEs for the phasing angle. So David and I tried to eyeball the azimuth and elevation, and I simulated the passes over Aachen using GMAT, an astrodynamic simulator, to generate CCSDS ephemeris files for the antenna pointing and the Doppler shift.
Yeah!
Не наблюдаю пока. Хотя вот начинает проявляться, похоже.
We managed to track the MS-13 and got a really clear voice reception from astronaut Alexander Skortsov, almost from horizon to horizon.
Да, понял.
Okay, so that was a wonderful day full of big impressions, not only for the summer school students I guess, but also for me and my team, which really did an awesome job. As it was our very first time we organized a workshop for such high profile guests. Let's have some rest because there is more to come the next day.
Hi, my name's Abby and I'm 23 and I study astronautics and space engineering at Cranfield University in the UK. I wanted to come here this week to learn more about something that you just don't get the chance to learn about in the UK, and you get to kind of put everything you've learned theoretically into practice experimentally. And the bit I've liked most about this weekend is seeing the final image that we get from the weather sats. Getting that data and seeing it in real life is pretty cool.
The APT analog signal shown here is received with our VHA Yagi array. From the SDR, the signal is then routed into the VX2 EMG tool, where it is then translated as the image you are seeing here. This image comes from a NOAA-19 satellite, which is an American weather satellite. The signal has been recorded at a maximum elevation of 60 degrees. The next two images have been recorded at a much lower elevation, all by the students of this summer showcase. The results are still very good. This is due to a correct manipulation and by the high antenna gain of a whopping 21 dBi.
So yeah, my name's Tom Bayliss. I've come over from Cranfield University, but I'm a part-time student. And my speciality originally on my bachelor's and my master's was mechanical and energy production, but I wanted to change into the space industry, so that's why I'm doing the masters I'm doing. And I'm here today at FH Aachen looking at the control room behind us, and today we've been connecting to radio stations all around the world, and it's been really cool. I've managed to download some audio files from the satellite and didn't succeed, but tried to convert it into weather images. And so seeing it, I managed to succeed yesterday, but on the FH Aachen equipment as opposed to my own laptop. And it was really cool to get some proper satellite photos myself. So, yeah.
So I made it. Yeah. Hydrate.
Sweating out my body brains.
And you can use the arm functions.
Alright.
Then I show you how to set up, because there's something missing. Yeah. Okay, you have it. And on the other monitor, you have here the decoder for that satellite. So this satellite is an amateur-radio satellite that is on a geostationary orbit. And what you can get from that satellite is its telemetry beacon.
This signal comes from the geostationary amateur-radio satellite QO100 and is brought into the control room via the internet using the WebSTR interface of the Gunhilly ground station.
Then the electronics makes that the frequency is not very stable. So you have all the time you have to correct. So the operator that is talking is correcting on his transceiver all the time the frequency.
Hi, I'm Sudhati. I'm from India and I'm studying in Luleå Technical University, Sweden. And I'm doing my internship at DLR Bremen. I'm here for a space showcase and in particular in Ekachakhan Space Operations Facility. And the best thing I like about it was it is totally run by students and they are doing so well.
Dynamic. Then it doesn't run into a self-oscillation. If it's too narrow, then it could start with self-oscillation.
So I think then the point that you're doing it yourself.
That's what I was trying. And another thing is also, since this is an SDR circuit, which has no filtering at all, if you listen to the whole bandwidth that this can the same thing. As soon as you have a signal.
Hi, my name is Tim. I'm from Cranfield University in England and I'm here at the Aachen Space Operations Facility and I've just been learning about all the types of information and different data and how to interpret from satellites that they can read at this facility, which has been super interesting.
This is now an experimental station. It's very new. We will track. We will have one more teleport for the next 3 satellites. Using this dish. We are not using S-band, but for now. But we use this guy here, which is a 7 centimeter. It's a really simple one. When we now will track FunCube, NileSat and the weather satellites, you will have definitely Doppler. And then you need to correct the Doppler by yourself.
Everyone has its own.
Okay. But it's nice because it really gives you a direct impression about Doppler frequency, and after a while, for us it was it's very interesting to also hear signal. And you get like a feeling for it if it's a good quality.
So now we can pretty much say, okay,
for that I can directly recognize if this is a PSK signal or if it's an FSK signal just by listening.
Yeah,
it's a noise that is different than the rest of the background.
Probably very low power transmission because it's so little bandwidth.
So for now, this is Max Valier?
Yeah, here. Max Valier.
Yeah, okay.
Hi, I'm Guillaume. I'm from France. I came here to learn a bit more about satellite tracking in Aachen. What I really like here is that I've been able to put into practice what I learned in my university about telecommunications, signal processing antennas. And that's quite cool because in my home university they are developing kind of ground station as well. So we can see here maybe a way of cooperation or to learn from each other, and that's great in the European frame to work like this now.
Yeah, so I'm Guillaume too, and I'm from the same university than the other Guillaume. So yeah, I have a telecommunication specialty, and I'm very happy to see how it's going on a real operation center. And it's a very nice project.
It's time to wrap up. First of all, what to tell, it was a really great pleasure for me to be allowed to give the lecture here on this workshop of the ASE Summer Showcase for mission operations and tracking of small satellites, and not only small satellites, but also big weather satellites. It was a really pleasure, first of all, because yeah, it's with people that is really interested in the thing. Also people, as I soon realized, that were already really well instructed or studied this the kind of things we do here. And yes, I really hope you enjoyed your stay here, and that it's the expectations you had on this workshop were finally met. As for this, we have a certificate for everyone. First, where it's explained what has been performed in this course, and of course your flight. And remember, everyone that comes here, even if you are a professor or a rector or whatsoever, has to do this flight. You did it, so you get a certificate, okay? So I start with Guillaume Chavanat. And here you still have to sign your name, and then you find your operator, because that operator has also to sign. Okay, so that's okay. Sudhiti Chand. Stephen George. Jack Leto Danes. Guillaume Thierry. Pablo Castel Orzocco. This almost sounds German. Andreas Fleckmann. Shashikant Gupta. Timothy Peterson.